The HP1000 system grew and grew as illustrated earlier, from the HP2114A to the HP1000M to the HP1000A RTE A. The Labka system installed on the HP1000M RTE3 with 4 BDU terminals in '79 supported a production of 200,000 analyses per year. Around the year 2006, the largest system on the A990 with RTE A had a production of more than 6 million test results per year, as shown here, a difference of more than 30 times. When the production of analyses on a single system was so great, it was because the one HP1000 supported 3 hospitals and also received tests from the general practitioners, the doctors in the county. This caused a production of more than approximately 25,000 patient test results on a busy day, and there were more than 100 staff involved, but only one HP1000. That this could be done at the same time as the system functionally was greatly expanded, that was largely due to the further development of the HP1000 and the RTE A system, which I will explain in the following, especially the development since the HP1000 RTE3 era. It can be divided as shown here. Much more hardware with improved performance. The basic construction and modification of the HP1000 hardware. The new advanced improved operating system RTE A and the network database image2 with the possibility for having a very short access time. The data register structure in the application and the extensive development of the application software. Let us start with the expansion and improved performance of the hardware. If you have already seen the chapter Booting the A990, you should have some understanding of cabinets and the type of cards that can be mounted in a cabinet. Here you see a listing of hardware on one of the largest A990 supported lab systems. As can be seen, there are 27 cards installed in the computer. It was therefore necessary to have a 20-slot cabinet and a 14-slot I/O extender as shown. As can be seen, there's a total of 32 MB of memory. That is the maximum memory that can be installed even in an A990. But it is 25 times more than used in the HPM system. There are 5 SCSI cards and as many as 14 multiplexer I/O cards, so you get a total of 112 serial inputs. Of external HP devices, we have 4 disk drives in a mirrored configuration and 64 HP 700 screen terminals, 16 times the number in the HP1000M installation. And in addition, there were 7 OMR readers, 10 printers, and 20 analyze machines. The 14 multiplexer panels with the 112 inputs can be seen on the right in the picture. But not only the quantity, but also the hardware performance was significantly improved. The CPU speed increased from 0.5 million instructions per second up to almost 10 to 15 million. However, the I/O bandwidth was still more moderate. The mapper technique was already introduced with the HP1000M series, but the functionality was further expanded. The basic instruction set from the old HP2114A was still contained in the A990, but the number of instructions had already been significantly expanded with the introduction of the HP1000M series. Index register, byte handling, etc. had been added. But further expansion came with the A series and the A990, including also microcode for controlling the new mapper system and for increasing of the process time, for example when executing frequently used Fortran code. The disk average had dropped from 37 milliseconds to about 4 to 7 milliseconds, and the transfer speed increased. Read cache had appeared in the disk. Here you see the SCSI disk type. It can still be bought on the net, so that's the reason for I have listed it here. The speed of the I/O controllers was increased. All I/O controller cards had DMA access, and the 1204D multiplexer had a FIFO I/O buffers from each of the 8 ports, which was essential for communication in terms of block mode communication with the many screen terminals and analyzed machines. For example, when the user has updated a VDU form in block mode and then activated the VDU send key, only relevant, and that is the unprotected fields, on the screen was transmitted to the MUX I/O buffer and transferred as one block via DMA, guided via the mapper to the application program data area almost without any program processing. A feature which was important considering the many terminals. Almost the same method was used related to analyzed instruments. The MUX could be ordered to send a data buffer via DMA when the user-defined end of block character was detected. The feature with the multiplexer and the real-time features in the RTE A eliminated the use of PCX as interface units. Many more improvements came with this new RTE A operating system. Improvements that work especially well with the HP 1000 hardware, especially if the system, as the system we are standing here, was delivered with a virtual code extension named the VC+. We had VC+ on all labs installation. To get VC+, we had to pay a little more for the operating system. It contained many nice features also for program development. Next chapter is about some improvement of the RTE A, demonstrated on the system. But just before we go to this chapter, I will show the size of the Labka application program code to illustrate that you can build a large application system with many programs and functions in an HP 1000 system like this. Then, next, about the RTE A.